Okay, so this way we're going to be looking at what's known as the division algorithm, which will lead on to looking at Euclidean algorithm. Okay, so what a division algorithm states that if A is a non-negative integer, and B is a positive integer, okay, then there exists unique non-negative integers Q and R such that A would equal B times Q plus R, and R would be greater than or equal to 0 but less than B. Okay, now that's actually a very fancy way to say that basically Q and R stands for, Q stands for quotient and R stands for remainder. That's where you get the letters from. So Q is more for quotient and R is the remainder. Okay, so basically what I'm saying is if you start with two basically positive integers A and B, normally A being the bigger one, then you can find a quotient Q, so how many times it B divides into A, with a remainder left over, if there is such one. Okay, sometimes you get no remainder, so that's why it could equal 0. Okay, so that's basically what that's saying. Okay, but it's got a powerful tool with that. So I'll just give you a quick example at how that sort of works there. Okay, so example 1, if A is 193 and B is 17, then how you'd work out what Q and R would be. Well, we know 193 would equal, and you work out how many times 17 can fit into 193. It fits in 11 times with a remainder 6. Therefore, Q would be 11 because it fits in 11 times, and R would be 6, which is the remainder. Okay, so that's what you'd be able to work out, how to work out Q and R from just given two numbers A and B. Okay, we'll look at a second example. Example 2. Okay, so we'll make the numbers a bit bigger. So if A was 581 and B was 23, okay, well 581 would be, well how many times does 23 fit into 581? Well, it fits in 25 times, so we times it by 25, and the remainder again would be 6. Therefore, this time Q would equal 25 and R would equal 6. Okay, so you can find the Q and R for any two sets of numbers that are positive, basically. Okay, and that there. So that's what's known as a division algorithm. Okay, basically how many times it goes in and remainders. We're going to use it now a lot more thoroughly to work out something that you've seen before as well in school, but probably not how we've done it. Okay, we're going to look at what's known as the Euclidean algorithm now. Okay, which is based on what the division algorithm is. Okay, so the Euclidean algorithm. Okay, so the Euclidean algorithm, bit of a capital there. So the Euclidean algorithm is used to find the greatest common divisor which you can write as GCD, okay, which also can be known as the highest common factor. You might have heard that terminology used. Okay, so greatest common divisor, highest common factor, same thing, of two or more positive integers where this cannot be done simply. Okay, so that last bit there is just saying that if you could probably find the highest common factor, greatest common divisor of a set of numbers, if the number's quite small, probably quite quickly in your heads, but if the numbers get quite big, okay, talk about thousands, okay, then Euclidean algorithm can get us that. Okay, so that's what we're going to do. So we'll look at an example to show you how this works, but it's based off the division algorithm. Okay, so that's why I showed you that bit first. So let's look at example 3. Find the GCD of 1147 and 851. Okay. Also, just put in brackets here how you could see this written as almost like coordinates. Okay. So if you've seen that written there in brackets, it means we're finding the greatest common divisor between those two numbers there. Okay, so let's have a wee go at that just now, okay? So basically how we're going to do this is we're going to use repeated applications of the division algorithm until we get RT equals 0, okay, which means that we'll have no remainder, so then the algorithm stops at that point, okay. Now, I'll show you an example, but then I'll state where the greatest common divisor is actually found, okay, so it's not actually your last line, but your last line proves that it stops, okay, so I'll show you that just now. So, let's have a wee go at this here. So we've got two numbers, 1147 and 851. We use the division algorithm. So start with the bigger number, 1147. So how we do this is we work out how many times 851 can fit into that first number, okay? It can only fit in once. So we times that by 1. But we're left with a remainder of 296, okay? If you took 851 off that, you would end up with a remainder 296. Okay, so that's my division algorithm, okay? But I'm going to continue it now. So what happens here is your number here now goes to this list, the left-hand side here. So 851. And what I'm now doing, I'm now finding out how many times that remainder fitted in 851. So how many times 296 fits in to 851, okay, and it can fit in twice. Okay, and if we put it in twice, what we're left with is a remainder 259. Okay, so that's what my remainder would be at that stage. Again, we're not finished yet because we don't have r equals 0, so again we're going to repeat the process. So 296 will move over, and 259 will move to where the b value would be. Okay, how many times does that fit into 296? Well, it can fit in once with a remainder 37. Okay, so again, no remainder equaling 0. Continue the process, so 259 moves over here, and 37. I need to work out how many times 37 can fit into 259. Well, 37 can fit in 7 times, and there's actually no remainders at that point. Okay, it can fit in 7 times and it completes 259. Okay, now what we do is we stop here. Okay, because I can't continue the process now. Okay, because I've got a 0. But where you find the greatest common divisor, it was the previous remainder. Okay, so that there is the greatest common divisor of 1147 and 851. Okay, the greatest common divisor was actually 37. Okay, so just a wee quick statement, hence greatest common divisor between 851, so I'll use my bracket notation, would be 37. Okay, so that's how you can find the greatest common divisor there. Anybody got any questions on that one there? Okay, right, we'll look at a second example just so that we get a bit of practice as well. Okay, so this is now example 4. Yep, example 4. We'll now look at finding the greatest common divisor between 1219 and 901. Okay, so we'll do that just now. Okay, so again, we'll start off the process using the division algorithm. So 1219, that'll equal 901. Then we need to work out how many times 901 can fit into that there. So we know it can fit in once, and the remainder would be 318. Okay, so that's me started off my process there. Okay, right, not got remainder 0, so we continue. So we move 901 over. We'll move the 318 over as well. And now we work out how many times 318 can fit into 901. So that can fit in twice. And it would leave us with a remainder 265. Okay. Again, no remainder equals 0. Repeat the process. Move the 318 over. That's going to be 265 times. Well, we know it can fit in once just by looking at the numbers there. The remainder we'd be left with would be 53. Okay. So again, still no remainder 0. Continue the process. 265 will equal 53 times, how many times can 53 fit into 265? Well, it can fit in 5 times, and it fits in 5 times exact, so there's no remainder. Okay, therefore we stop. Our previous remainder was our greatest common divisor, hence greatest common divisor between the numbers 1219 and 901 was 53. Okay with that, folks? Okay, perfect. Right, thank you.